I just finished my first activity of the day. It's a run, just under like a half marathon. Kind of like 12.9 miles or something like that. Took a little bit more out of me than what I liked, but pretty fueling. Got some Powerade with some Sprite mixed in, gummy bears, gummy sharks, sunflower seeds, some sodium fat, all that fun stuff. But I think I burned like close to 1,600 calories so far, so still got a long ways to go. But we're getting there. So.
All right, we're gonna do some calculations here. And before I begin, I just wanted to explain, I'm only gonna do the calculations for the big 4 workouts I did: my run, my mountain bike, my road bike, and my swim. I burned more calories. I did a little bit of stair stepper workout. I went shopping at Walmart. I walked around. I biked to the rec center. Those things kind of just burned like around 100 calories each. And so I'm just going to do the big 4 workouts that burned a lot of calories. So we're going to start off with my run in the morning. As you can see above there, I've kind of already done some conversions. I did my distance into total meters. I did my average pace into meters per second. And I did my move time, converted that to seconds, converted my weight into kilograms. And I apologize, it kind of got cut off here during this recording. And then the elevation gain is negligible because it was an out and back, so every foot I gained, I lost. So we start off calculating work, which I just did down here, and we can take, it doesn't show it on that little screenshot, but I know that I burned 1620 kilocalories. So we can take 1620 kilocalories, and we know that 1 kilocalorie is 1,000 calories, and we know that 1 calorie is 4.184 joules. And so multiplying all those together, converting, the work that I performed was 6,778,080 joules. So a lot of work. It took me quite a bit of work just to figure out how to say that. But from the work, we can do a lot more and calculate a lot more. And the work's kind of given to us because we already had the kilocalories, which is nice. But we can bump down. I wanted to calculate the power, the wattage it took me to kind of move. So we can use the equation power equals work over time, or I wrote joules over time there. So we can take the total work, again, that 6,778,000 number, and we can put it over the time, which we converted from the total move time to 6,285 seconds. And we can divide work by time, and we get a total number of 1,078.45 joules per second. And that's also can be put into watts. And so you can think about wattage as like far as appliances in your home. You have like 100-watt bulbs, so I could have power close to 1,100-watt bulbs for that time period. Or I even looked up a fridge. A fridge takes roughly around 800 watts throughout the day, throughout 8 hours in the day, because it kind of turns off and on, which is less than I thought. But according to that, I could power a fridge and like 2 or 3 light bulbs for an hour and 45 minutes. So your power's out, you can throw me on a treadmill, and for an hour and 45 minutes, I guess I could power your fridge. But so with that, we have our work, we have a power, and then I wanted to, again, it's cut off down there, but I wanted to calculate the force, the constant force that was being exerted in order for me to continue to move forward. And so we can use the equation work equals force times change in x, or change in distance. And when we reconfigure that, we can find force equals the work over the change in x. And so we can just throw our work over there in the numerator. And then for the denominator, like I said, I already converted distance into total meters. And so that we can just throw our work over our meters. which is 20,760.54 meters. And that will be our force. And this is measured in newtons. Newtons is a unit that is kilograms times times meters over seconds squared. And so anyway, our constant force is 157.97 newtons. That's the constant force it was taking me to continue to move forward. The force being exerted at any point in time, really, throughout the run. So the last thing that we are going to calculate for our run is the kinetic energy. So we can use the equation kinetic energy equals a half times mass times velocity squared. And this will be the kinetic energy, like average kinetic energy. At any point in time, if we take my kinetic energy at any time during the run, this is most likely what it would be around. This is the average kinetic energy. So we can use my previous kind of conversions up there. We know that my weight is 78.93 kilograms. And then we know that the velocity is 3.35 meters per second. And that was converted earlier. And so we can square that number. Put the units in there. And so from that, the kinetic energy at any given point in time on average is going to be around 442.9 joules. And that's my average kinetic energy. And like I said, we are only going to do this for the first 4 workouts. But I've gone through how to calculate. I'm going to use these same methods for each of the next 3 workouts: my mountain bike, my road bike, and my swim. And so I'll just do those calculations, and then we'll go to those next. So, all right. So I've done the calculations now for all of these. I didn't write them down, and unfortunately, it cut off the things. But total work for my mountain bike was that number at the top, and then my average watts was 500 watts. Average force 157 newtons. And then 396 joules for my kinetic energy. Stationary bike, got a flat tire on my road bike. But I was really surprised the kinetic energy was 3,077 at any given time. And then I figured out it's because velocity is squared. And I was going close to 20 miles an hour at any given point. And because velocity is squared in that kinetic energy equation, it makes sense that my kinetic energy was so high. Which is pretty crazy though. And then another thing that surprised me when I was calculating for swim was the force it took me to swim. It makes sense, I was going pretty slow, but just the drag from the water, you have to have a lot more force exerted to just move forward at all, which is pretty interesting. But it was kind of cool to see that played out. And this is my total calculations. So work was, I can't even say that number, in the trillions? No, that's billions. Billions, my bad. I think, or no, 211,292,000. Something like that. 21,129,200 joules. Watts, 784 watts on average was what I was exerting. So like we said earlier, that's close to 8 light bulbs or a fridge on average. Average force took me to move 184 newtons. Average kinetic energy 981.